Hello, welcome to Astronautics for Exploit. This is Dr. Ayeshala Ogundele. Mars habitats, future homes on Mars, and endeavors to make humanity multiplanetary. The focus points of my presentation are as follows: Mars habitat, challenges of Mars habitat, types of Mars habitation, and caves of Mars. For many decades, humans have been envisioning living and working in space. This, therefore, propelled the urge to design and develop a habitable place where humans can live and work on Mars. Mars habitat, a conditioned environment on Mars, which must contend with Mars surface conditions that include extreme cold, low pressure, almost no oxygen in the air, and high radiation, is a proposed habitation system that is currently being planned and designed to provide a safe place for astronauts on Mars, a system for radiation protection, and provision of life support. Mars habitants are faced with various challenges, such as maintenance of an artificial environment, shielding of the habitats from intense solar radiation, protection from the toxic Martian atmosphere. Various Mars habitats ideas have been put forward. For example, the use of a Martian cave or level tube, which has the advantage of serving as radiation shade. Two different forms of habitation, temporary and permanent habitations, are being proposed. For the temporary habitat, the proposal is that the habitat does not need complete shading from radiation, since the habitat is for a short period of time. This type of habitat can be manufactured on Earth and transported to the Mars. Mars habitat. A Mars habitat is a hypothetical place where humans can live on Mars. Mars habitats will have to contend with surface conditions that include almost no oxygen in the air and extreme cold conditions. The picture here shows Mars ice home designed for a Mars base. Transportation cost. The extreme cost of transporting building materials to the Martian surface, which by the year 2010s was estimated to be about $2 million per brick, is a big challenge. Due to lower mass than Earth's gravity, there are stronger solar radiation and temperature shackles and high internal forces needed for Mars pressurized apparatus to contain air. The picture here shows 1990s era NASA design featuring span camp type orbital landers. Uses of Mars regolith. Scientists propose the use of locally available Mars regolith to shield against radiation exposure, or to use transparent ice to allow non-harmful light to enter the habitat. Mars habitat design involves the study of local conditions, including pressures, temperatures, and local materials, especially water. NASA vision for the first human on Mars is shown in this picture. Challenges of Mars habitat. Humans require a pressurized environment at all times and protection from the toxic Martian atmosphere. Mars habitats have challenges of maintaining an artificial environment and shielding from intense solar radiation. One of the larger issues of constructing Mars habitat lies in getting to Mars, which means escaping Earth's atmosphere, sustaining the journey to Mars, and finally landing at the surface of Mars. The picture here shows Mars habitat with astronauts. The amount of energy required to transfer material to the surface of Mars is an additional task beyond simply getting into orbit. Maintaining Mars climate. One of the challenges for Mars habitats is maintaining the climate, especially the right temperature in the right places. Electronic devices and lights generate heat that races in the air, even as there are extreme temperature fluctuations outside. Illustration of a Mars habitat concept is shown in this picture. Mars surface temperature challenges. and the ranges as follows. Average of minus 80 degrees Fahrenheit, polar locations in winter, minus 185 degrees Fahrenheit, equator in summer daytime as high as 70 degrees Fahrenheit. Building of an industrial complex on Mars is shown in this picture. Medical problem. One problem for medical care on Mars missions is the difficulty in returning to Earth for advanced care and providing adequate emergency care with a small crew size. A crew of 6 might have only one crew member trained to the level of emergency medical technician and one physician. The picture here shows Team Search Peace Corps of New York 10 concept of Mars habitat. Medical risks include exposure to radiation and reduced gravity, and one deadly risk is a solar particle event, which can generate a lethal dose over the course of several hours or days if the astronauts do not have enough shading. Examples of acute medical emergency scenarios for Mars missions are wounds, lacerations, and burns. The picture here shows concept of Mars habitat. Types of Mars habitation. There are two forms of Mars habitation being proposed, temporary and permanent habitation. A short-term stay on the surface of Mars does not require a habitat to have a large volume or complete shielding from radiation. The situation will be similar to the International Space Station, where individuals receive an unusually high amount of radiation for a short duration and then leave. The picture here shows illustration of a multi-storied cylinder Mars habitat that can withstand the planet's hostile environment. Permanent habitation. Long-term permanent habitats require much more volume and thick sheeting to minimize the annual dose of radiation received. This type of habitat is too large and heavy to be sent to Mars and must be constructed, making use of some local resources. Possibilities include covering structures with ice or swell, excavating subterranean spaces, or scaling the ends of an existing liver tube. Artist's impression of what a colony on Mars could look like is shown in this picture. A larger settlement may be able to have a larger medical staff, increasing the ability to deal with health issues and emergencies. A small expedition of 4 to 6 may be able to have one medical doctor, and an output of 20 might be able to have more than one nurses. An artist's impression of mining operations on Mars ahead of a potential colony of humans on the red planet is shown in this picture. Caves of Mars. The Caves of Mars project was an early 2000s NASA program to assess the best place to situate the research and habitation models that a human mission to Mars will require. Caves and other underground structures, including Martian lava tubes, canyon overhangs, and other Martian cavities, are thought to be potentially useful for crew missions. Various components of the Mars output proposal is shown in this picture. Caves of Mars program studied designs for inflatable models and other such structures that will aid the astronauts to build a livable environment for humans and Earth creatures. Research findings show that caves of Mars could offer access to minerals, gases, ice, and any subterranean life that the crew of such a mission will probably be searching for. An artist's concept depicting long-range exploration on the surface of Mars using pressurized rovers is shown in this picture. Advantages of using caves are less atmospheric temperature variations in caves than on the surface of Mars. Caves protect life forms and equipment from harmful solar and galactic radiation. Caves protect from dust storms and micrometeorite impacts. The picture here shows artist's concept of living quarters covered with swell to shield the Mars crew from sun's radiation. Other advantages of caves on Mars are exploring caves is a key scientific interest, as it makes it easy to study the geology, history, and possible presence of life on Mars without heavy excavation equipment. The ability of pressuring caves to make them more habitable to human life forms allows easy extraction of subsurface materials such as ice and minerals. The picture here shows a lava hive, a modular structure for Mars. For more information, contact Astronautics for Exploit. You've been watching and listening to Mars Habitats, future homes on Mars and endeavors to make humanity multiplanetary, presented by Dr. Ayoshola Ogundele. With the focus points, Mars habitat, challenges of Mars habitat, types of Mars habitation, and caves of Mars. Thank you.